Let's look at OpenStax College Physics, Chapter 17, Problem 47. What is the length of a tube that has a fundamental frequency of 176 Hz and the first overtone of 352 Hz if the speed of sound is 343 meters per second? So let's write down the things that we know. We know that the fundamental frequency is 176 Hz. And we know that the first overtone is 352. I'm going to write this as just F is 352 because I don't quite know what that means. We know that the speed of sound is 343 meters per second, and we're looking for the length of the tube. So why did I say that I don't know what this means? Well, I don't because there are two different types of pipes that we can be dealing with. One would be open at both ends, and the other one could be closed at one end, open at the other. So if we have a pipe that is open at both ends, then we know that there has to be an antinode at both ends. If we have a pipe that's closed at one end, then we know that it has to have a node there and an antinode at the open end. So we've derived equations before for these different scenarios for the frequency and ended up with F sub n being equal to NV over 2L for a pipe that's open at both ends, and F sub n equal to NV over 4L when we have a pipe that's open at one end and closed at the other. But what's very important here is the n, because in the first scenario, the n is a positive integer, 1, 2, 3, and so on. Whereas for the second scenario, we have n being a positive odd integer, 1, 3, 5, 7, and so on. So that's why I said that I don't know what to write in the for the f here. Would I write this as f2 or f3? I don't know, but I can figure it out by simply dividing the two. So I have f over f1 is 352 Hertz divided by 176 Hertz, and that gives me the order, that gives me the n, and that is just 2. So looking back at the equations, this one has a 2 in it, this one doesn't. So this is the model that we have. The tube is actually open at both ends, so we have to use this equation. So let's do just that. We have then F, we can use either 1 or 2, I'll just use F1, is equal to 1V divided by 2L. And from here we solve for L, and L will be V over 2F1, and that would be 343 meters per second divided by 352 Hertz. That's 2 times 176, and we get 0.974 meters for the length of the tube. Now I said that I could have used the other one as well, so I would have had F2 is 2V over 2L. So that means that L would be V over F2. So that is again 343 meters per second divided by 352 Hertz, and that comes just from the F2, and that's again 0.974 meters. So I could have used either one of the frequencies that we were given.